So this is a video for percentage ionization for the weak acids, and this is very useful to specify the amount of the weak acid that has dissociated in the solution. So either we can call percentage ionization or percentage of dissociation for the weak acid. And how we calculate, this is the formula: amount dissociated in molar concentration divided by initial concentration multiplied by 100. Or we can also write for weak acid hydrogen ion concentration in the equilibrium and initial hydrogen ion concentration, basically it is a weak acid concentration, and multiplied by 100. And how we get this information? So for weak acid we use ice chart, and the concentration which you will calculate it in the equilibrium concentration of hydrogen ion divided by initial concentration of acid multiplied by 100. So we can use any of these formula, or you can understand through this way. So let's see few examples so that we can understand how we can write this percentage ionization questions. So here is one example that calculate the pH of 0.175 molar hydrozoic acid, that is HN3 solution. The acid dissociation constant Ka for hydrozoic acid is 1.9 times 10 - 5. So, and this is the structure of hydrozoic acid, which is little different, completely different actually than ammonia. Ammonia have NH3 and hydrozoic acid have HN3. So there are 3 nitrogen, here is 3 hydrogen. So let's start to work on this one. I have already have written part, so I will use my solution for here. So we'll use this written part. So we will start first from here. Hydrozoic acid have 0.1, and this is the weak acid. So we'll write a weak acid equal in equilibrium sign dissociation hydrogen ion and initial and anion. So initial concentration is given. We will make ice chart 0.175, initial concentration 0, then change will be minus x plus x and then plus x. So because there is a 1 to 1 to 1 mole ratio for each, and then during equilibrium it will be 0.175 minus x, here x and x. So once we will write the Ka expression for this calculation, it will be Ka hydrogen ion concentration anion divided by acid. So this will be x multiplied by x, that will be become x square, and then 0.175 minus x. So after that what we are going to do here, that since we can see that this amount is very small, since Ka value in the question is very small, so here you can see the Ka value is given which is 1.9 times 10⁻⁵. So minus 5 means very small Ka. And for all weak acids Ka value will be very small, so we can drop the negligible, we can consider this x, which is a change, will be negligible. So we can drop this one, and then we can calculate directly. So this will become once we will rearrange, so x square will be equal to Ka multiplied by 0.175, and then once we will multiply this product, and then this will be equal to x square, and after that we will take a under root on both side. So x square will become under root 3.3 times 10⁻⁶, and once we will take the under root, we will get the concentration of x value, and the concentration of x value will be equal to the concentration of hydrogen ion. And from here we can calculate the pH for this weak acid. pH will be negative log of hydrogen ion concentration, and which is negative log of 1.8 times 10⁻⁴ - 3 molar, and then once we will calculate, the pH will be 2.74. and then in the question they are asking what is the percentage dissociation. So percentage dissociation for this acid will be hydrogen ion concentration in equilibrium divided by initial concentration. So hydrogen ion concentration in equilibrium we have just calculated, which is this one x, and then initial concentration for the acid is given in the question 0.175 molar and multiplied by 100. So once we will solve this question, we will get around 1% dissociation was observed. So this was the one example. Let's see one more. Another example is here, that if we dilute this acid 10 time, further 10 time, what will happen? So here we have calculate the pH of 0.0175 molar hydrozoic acid, same solution. Initially in the previous question we were calculating the pH for 0.175 molar, and now we diluted 10 time, 10x, and now we are going to calculate. So exactly same, we have to write the ice chart first. Initial concentration is 0.07175 and hydrogen ion 0, A minus 0, then change will be minus x plus x plus x. E concentration will become in equilibrium 0.0175 minus x and x. Then we can write the equilibrium expression, Ka will be equal to product divided by reactant, hydrogen ion, anion, and then the equilibrium concentration of acid. So this will become x square, and then since again the Ka value is very small, so we can drop this x change from here, and otherwise it will be quadratic equation. So x square, and then from here Ka value is already given, so we can calculate the x value. So x square will become 0.0175 multiplied by Ka, which is 1.9 times 10 to the minus 5 under root of this whole product. So under root of this one will give us the concentration of hydrogen ion, which is 5.8 times 10 to the minus 4 molar. So this is my initial equilibrium concentration of hydrogen ion. Now we have to calculate the pH. So pH will be negative log of hydrogen ion concentration, which is negative log of 5.8 times 10 to the minus 4, 3.24. You can just recalculate everything and using your calculator and see if it is everything is correct. And once we will do the percentage ionization or percentage dissociation for this expression, for this reaction, this will be again equilibrium concentration of hydrogen ion divided by initial concentration multiplied by 100. Initial concentration we have just calculated 5.8 times 10 to the minus 4 divided by initial concentration of acid as already given in the question multiplied by 100, then it would be 3.3%. So now what we can do, we can compare these two results with our previous question, that if we are going to compare the two problem, these two here, in the previous concentration we have 0.175 molar hydrogen, and after that we dilute 10 time. So hydrogen ion concentration, you can see it also diluted and pH increases. So pH increases means it is now less acidic, but the percentage dissociation increases, right? So as the concentration of the weak acid decreases, in the solution, percentage increases, hydrogen ion concentration decreases, and pH increases. So these effects happen once we dilute the weak acid solution. So if we are diluting weak acid solution, percentage ionization will increase and hydrogen ion concentration decreases and pH will increase. So next we will see one more example, basically two more example for related to this topic. Here we have another example on the niacin. Niacin is a vitamin B and 0.02 molar solution. Niacin has a pH of 3.26. What is the acid dissociation constant for niacin, and what is the percentage dissociation ionization? So this is the chemical structure of niacin or vitamin B. So let's study this type of, this is again whenever we are working with the weak acid we have to use ice chart. So initial concentration for this acid is given, which is 0.02, and hydrogen ion and product will be 0, then change will be minus x plus x plus x, and then we can write the equilibrium concentration. Equilibrium expression will be product divided by reactant concentration, and then x square, and then 0.02 minus x. So from here, since they have already given the pH value, so we can find out what is the x. So x is equal to hydrogen ion concentration. X is equal to hydrogen ion concentration, which is equal, since we know the pH, so we can calculate the hydrogen ion concentration using this formula 10 raised power minus pH. So 10 raised power minus pH is 10 raised power minus 3.26, which is equal to 5.5 times 10 raised minus 4. This is my x, or this is my hydrogen ion concentration, and once we know the x, we can replace this value into this formula, which is Ka is equal to 5.5 times 10 raised minus 4 raised power 2 and 0.02 times 10 raised minus x, which is 5.5 10 raised minus 4. Once we will calculate all this math, we will end up this Ka value, and Ka value is again very small. So, and now they are asking in the question that we have to calculate the percentage dissociation or percentage ionization, which is hydrogen ion concentration in equilibrium divided by initial concentration. So hydrogen ion concentration we have just calculated from this pH and divided by initial concentration multiplied by 100. So this will become very small percentage dissociation, which is 0.078. So this is the third example for the percentage dissociation and percentage ionization. So we have one more question related to this topic, which is the Ka for niacin is 1.5 times 10 raised power minus 5. What is the pH of 0.01 molar solution, and now what is the find out percentage dissociation? So this, let's see, this is question is again in the same way we have to solve. We have to write the ice chart and write down the initial concentrations, change, and equilibrium concentrations. Then let's remove this paper, and then once we will write, it will become x square 0.01 minus x, and this is the Ka value. So here this I would like to show you, you can see if even this is very small, so we should drop this change, and if you will not drop this one, if you will not drop the change, then what will happen? If you will keep going, x square will be 1.5 times 10 raised to minus 5, and in parenthesis 0.01 minus x. Once you will open, you will end up this equation, which will be equal to like quadratic equation. So that is why it's always easy if you see very Ka is very small, then we can drop the this change. Once we will drop this change, we need not to go to the quadratic equation, we can go directly route from here to here. So Ka will be equal to x squared 0.01, and now we can calculate x value, which is already K is given, and 0.01. Once we will solve the math, x value will come 3.87 10 raised to minus 4, and from here we get the hydrogen ion concentration. Once we know the hydrogen ion concentration, we calculate the pH, which is negative log of hydrogen ion concentration, and negative log of hydrogen ion concentration is 3.87 times 10 to the minus 4. Once we will calculate using calculator or negative log table, we will get it 3.41 pH. And now they are asking to calculate the percentage dissociation. So percentage dissociation will be hydrogen ion concentration in the equilibrium divided by initial concentration of hydrogen ion, which is equal to the acid concentration. So acid concentration is given 0.01 and hydrogen ion concentration we have calculated from here. So and percentage dissociation will be 3.87%. So these were the 4 example about the weak acid, and how we can calculate the pH of the weak acid and how we can calculate the percentage dissociation or percentage ionization. In the next video we will study about the polyprotic acids.